Hello everyone, today we would like to introduce our work for the AI planning for autonomy project 2, namely PACMAN Capture the flag. Our group has 4 members, as you can see on the slide.
This project requires us to balance offense and defense, so we have decided to have one agent for offense and one agent for defense. The offensive agent will be using value iteration algorithm and the defensive agent will be using A star heuristic search algorithm. In this project, we applied 3 different techniques, namely A star heuristic search algorithm, value iteration, and model based MDP with deep Q learning. So value iteration for offensive agent. We adopted the Markov decision process that produces policy using value iteration approach. Rewards are assigned to different objects present on the map like food and enemy and capsules. Using the rewards, we set a number of iterations are run at each game step to compute the best action based on the optimal policy. We set positive reward for food and negative reward for enemies. And some of the challenges faced are the offensive agent was not aware of the enemies following it while it was trying to eat food. This was solved by making the agent identify if the enemy is close by and run home. The agent comes back home if it has eaten enough food or if the time left for the game to end is less. Once it reaches home, it does not try to go back to eat the remaining food. Another major drawback is that offensive agent gets stranded in the middle of the map because one of the enemies is blocking all the paths to the enemy ground. In this case, the agent does not do anything but stay in the middle of the map.
And A-star heuristic search was used for the defensive agent. The A-star search uses maze distance as a heuristic function and allows our defensive agent to find the shortest path to a goal set by us. While in patrolling mode, the goals are 2 food positions. This allows the agent to move between the food positions and patrol our territory. In chasing mode, the goal is the position of the enemy Pac-Man. The biggest challenge using A-star search was setting different goals for our algorithm. We wanted the defensive agent to go from goal to goal to patrol effectively, but could not find a way to change the goal of the A-star algorithm once the initial goal was reached. And the second challenge was finding an effective way to patrol our territory. But we realized they ended up using a moving agent as it would increase the chance of detecting enemies.
And in this demo, we are going to see some of the challenges that were faced during building the model. In the first video, we can see that the agent is getting cornered and eaten by the enemy. And in the second video, we can see that the agent is always followed by the enemy and the agent does not try to get to a cover or any safety. And another challenge was that once the agent has eaten all the food and the game is going to end, the agent just sits in the middle of the map and does not do anything. So, in order to solve all these challenges, our strategy was to make the agent eat the food, and when it is chased by an enemy, get back to the home. And if there is remaining food to eat, it gets back to the enemy territory to eat the food.
And this is our defensive agent in action, where now it's patrolling the territory waiting for an enemy to enter its sight range. And still patrolling, and once he sees the enemy, it goes to the enemy's position and kills the enemy, and then after that it keeps patrolling till it sees another enemy.
Deep Q learning is a reinforcement learning approach to building an agent. It uses a convolutional neural net to approximate the Q values from the whole game grid. These values get more and more accurate during training and eventually pick the best possible action according to the rewards it's after. During training, it uses multi-armed bandit strategy to decide which action to take. It has some chance of taking a random action which decreases as training goes on, since the predicted Q values get more accurate. The main challenges with this approach was figuring out how to calculate the gradients, incorporating training sessions within the flow of the game, deciding when to train, and trying to put all the pieces together on time. so that there would be enough time to train the agent.
For the future improvements, the first improvement is that both agents has interchangeable roles depending on the score and scenario. The second is about the offense strategy. The reward setting strategy needs to be handled better. With the better reward, the agent will be weak to take decision. The agent become uncertain in case when there is a food nearby and a chasing opponent. In terms of the defense, we should find a better way to patrol our territory. Sometimes the defensive agent will be patrolling but unaware of our food being eaten out of its sight range. This can be dealt with if we can identify where our food is different from